Bismillahirrahmanirrahim. Assalamu alaikum. My name is Mariam Akhtar and I'm from the Department of BS Chemistry. My ID is 004 and this is a course of Industrial Chemistry. And the topic that was assigned to me was of water oil repellent finishes, in which I'm going to discuss fluorochemistry, C6 and 6-8 chemistry and its side effects, how they are tested, and how the number of washing can be improved. So let me talk about the presentation layout, in which I'm going to tell you the repellent finishes, what are the purpose of the repellent finishes, what is the chemistry behind the repellent finishes, what are the types, and how they actually work, what are the mechanism. Repellent chemistry with its pros and cons includes paraffin, silicone, stearic, melamine, and FC-based. And the testing parameter include physical and chemical testing, troubleshooting, what is impact on the environment or on the ecosystem, and at last I'll conclude the whole presentation. So let me start with this introduction. Finishes that repel water, oil, and dry dirt are important in all the parts of the textile marketing. Why? For clothing, home, and technical textile. Water repellency is achieved using different products groups, but oil repellency is attained only with fluorocarbon polymers. The waterproof textile should be withstand with the hydrostatic pressure exerted by the column of the water, and before the first drop of the water penetrates through the fabrics. In practice, this is mostly achieved with coating, which have the disadvantages of stiff handle, lack of air, and vapor permeability, and consequently poor water comfort. Undesirable fabric properties are often found with repellent finishes. These include problem with the static elasticity, poor solid removal in aqueous laundering, stiffer fabrics hand, growing during aqueous laundering, and increased flammability. Some fabrics properties are often improved by the repellent finishes, which includes better durable, press property, more rapid drying and ironing, and increased resistance to the acid bases and other chemicals. So what water repellency of the fabrics means? Water repellent fabrics are those which resistance being wetted by the water, and water drops will roll off the fabrics. Here we can see that the roll of the water from the fabrics. Fabric resistance to the water will depend upon three factors: nature of the fiber surface, porosity of the fabrics, and dynamic force behind the impacting water spray. Now I'm going to talk about the chemistry of the water oil repellent. In mechanical incorporation of the water repellent product in the fabrics or the fiber, for example, paraffin emulsion. And if we are talking about the fatty acid resins, chemical reaction of the repellent material with the fabric surface. The formation of the repellent film on the fiber surface, for example, silicone and fluorocarbon-based product. The final approach is used by the special fabrics construction. So this repellent technique of the finishing can be confused with the waterproofing. So it must not be confused with the waterproofing, because waterproofing is just the prevention of the passage of the both air and the water through the fabrics. So we should know the difference between the water repellent fabrics and waterproof fabrics. Water repellent fabrics have open pores and are permeable to air and water. But in the case of waterproof, we can see that it has fewer open pore and less permeable. Water repellent fabrics will permit the passage of the liquid water once hydrostatic pressure is high. Waterproof fabrics are resistant to the penetration of the water, which are having high hydrostatic pressure. A fabric is made of water repellent by depositing a hydrophobic material on the fiber surface. However, in the case of the waterproofing, which requires the filling of the pores as well as the depositing of the hydrophobic material on the fiber surface. So what is the purpose of the water repellency? For certain uses such as trypanium, umbrella cloths, raincoat fabrics, etc., it is required to give this type of finish, as these type of fabrics are generally used against the air and the water in normal life. This finish makes the wearer feel uneasy and uncomfortable as air circulation is not there. What is the mechanism of repellency? Repellent finishes achieve their properties by reducing what? Reducing free energy at fiber surfaces. If the adhesive interaction is between the fiber and the droplet of the liquid that are placed on the fiber are greater than the internal cohesive interaction within the liquid, the drop will be spread. So the cohesive interaction must be greater so that the drop will be spread. If the adhesive interaction between the fiber and the liquid are less than, then the drop will not spread. So adhesive forces play a very important role. Here is the lining, and here we can see that moisture vapors evaporates and rain and wind stay out. This is the outer material. Surfaces that exhibit low interaction with the liquid are referred as low energy surfaces. Here we can see that the surfaces which have very low interaction are referred as low energy. Their critical surfaces energy or surface tension must be lower than the surface tension of the liquid. While we can see that the surface tension of the water is greater than the surface area of the oil. Therefore, oil repellency finishes with fluorocarbon always achieve water repellency, but fluorine-free product, for example, silicone, will not repel oil. Low energy surfaces also provide a measure of dry soil repellency by preventing the soil particles from strongly adhering to the fiber surfaces. Now I'm going to talk about the mechanism of repellency of different ways that low energy surfaces can be applied to textile. Because in the previous slide, we have seen that the low energy surfaces on the fabrics. Mechanical incorporation of the water repellent product in or on the fabrics and the fabric surfaces. For example, these are paraffin emulsions. The chemical reaction of the repellent material with the fabrics are fatty acid resins. And the final approach is use special fabrics construction. Water repellent finish. If the fabrics allow air but prevents water to pass through it, it is known as water repellent finish. Water repellent are chemical finishes. Resist the prevention of the water into the fabrics and permit the penetration of the moist and air into the fabrics. There are three types: non-durable, semi-durable, and durable. So line-wise, I'll tell you what is the difference among three non-durable finishes. This type of water repellent finish is usually based on the paraffin, wax aluminum, acetate emulsion. Non-durable finishes do not provide satisfactory resistance to liquid. For example, dry-on Repellex. Semi-durable finishes. These are X or salt solution. These are emulsion of the fabrics in laundering. They aid resistance to dry cleaning. For example, dry-on AB and nylon V. Durable finish is the third type of the water repellent finishes. There are several types of the durable water repellent finish. For example, paraffin compounds and melamine resins and steramides compound and silicone compounds. In paraffin compound, it is applied to cotton. It's endure repeated washing as well as dry cleaning. It's improved the fabric's appearance. In the second type, we will see it is used on the cotton and rayon, etc. It has excellent and good tolerance value to the laundering. And in the third type, silicone compounds, will see that it is excellent repellent. The finish is used more resistant to dry cleaning than to laundering. And the example of the durable finishes are Zippel, Zillan, etc. Now, I'm going to talk about what is the chemistry behind the repellent. So these three are the types for which we can explain the chemistry behind the repellents. Paraffin repellent, stearic acid and melamine repellent, silicone water repellent, and fluorocarbon-based repellent. So the first one is paraffin repellent. These are one of the earliest water repellent. They are the fatty acid metal salt used but not repel oil. Typically, the products are emulsions that contain aluminum and other fatty acids. These materials increase the finish adhesion to the polar fiber surfaces by forming a polar-non-polar junction. As this is shown into the figure, and we can see that there is a polar and non-polar junction in the structure of the fatty acids. The paraffinic portion of the repellent mixture is attached to the hydrophobic region, while the polar end of the fatty acid are attracted to the metal salt at the fiber structure. These finishes can be applied by the both exhaustion and padding. They are compatible with the most kind of the finishes, but they increase flammability. Although they are available at relatively low cost and generate uniform waterproof effects, but its lack of durability to laundering and dry cleaning. This is the drawback of this repellent. If we are talking about the second type, stearic acid melamine repellent, compound that are formed by reacting these both with the melamine is known as melamine and stearic acid repellent. Constituent other class of the water repellent material, for example, this is shown in the figure. It is a derivative of this compound. The hydrophobic character of the stearic acid groups provide the water repellency. So how the repellency come from is from the stearic acid group, while the remaining N-methyl groups can react with the cellulose or each other and make a cross-linking to generate the permanent effects. Advantages of this repellent include increased durability to laundering and full hand impart to treated fabrics. Some products of this type can be effectively applied to exhaustion procedure. Their use as extender for fluorocarbon repellents is now increasingly replaced by the boosters. Disadvantages of this repellent include problems that are stable to durable press finishes, a tendency to exhibit finish mark-off, and abrasion resistance, change in the shade of the dyed fabrics, and release of the formaldehyde. Polydimethylsiloxane. It is one of the derivatives of the silicone water repellent, and it's used as a water repellent that can form the hydrophobic layers around the fibers. The unique structure of the polydimethylsiloxane provides the ability to form hydrogen bond with the fiber as well as display the hydrophobic outer surface. Here we can see that ours are from hydrogen bond, and this is the structure of the polydimethylsiloxane on the fiber surfaces. In order to gain some measures of durability, silicone designed as a water repellent treatment usually consists of three components: silanol, silane, and the catalyst such as tin octate. These are the structure of silanol, silane, and tin octate. The catalyst enables not only moderate condensation condition but also promote the orientation of the silicone film on the fiber. The outward oriented methyl group generate the water repellency. Here, which group generate the water repellency? Methyl group. During the drying step after pad application, the silanol and silane component can react to form three-dimensional crossing sheet around the fiber so that water repellency can be increased. This reaction is often completed after storage of 1 day, that providing full repellency. The silicon hydrogen group of the silane are reactive links in the silicon chain, which generates the crossing or being oxidized by the air or hydrolyzed by the water to hydroxyl groups. These hydroxyl groups may cause further cross-linking, but if too many of them stay unreacted, their hydrophilicity will decrease their repellency. Now let's see what is the advantages and disadvantages of the silicone water repellent. Silicone water repellent advantages. It includes a high degree of the water repellency at the relatively low 0.5 to 1% on weight of the fabric concentration. It has very soft fabrics can improve durability and improve shape retention. And some modified silicone repellent can be exhausted applied to pressure sensitive fabrics. If we're going to talk about the disadvantages of the silicone repellent, we will see if excessive amount are applied, then silicone double layer with the polar outside will be formed. Only moderate durability of the laundering will be, and the moderate durability to dry cleaning. In addition, the wastewater, especially the residual bath from these finish application process, are toxic to fish. Here we can see that it is also toxic to the aquatic life. FC-based repellent include provide the fiber surface with the lowest surface energy to all the repellent. This is the preparation of the perfluoro containing the acrylic polymers. Both oil and water repellency can be achieved through FC-based repellent. And FC-based repellent are synthesized by incorporating the perfluoroalkyl group into acrylic. This is acrylic and this is perfluoroalkyl group are incorporated, and then monomers are formed, and then it is polymerized and formed into FC-based repellents. Originally, the perfluoroalkyl groups were produced by the electrochemical fluorination, but today they are produced by telomerization. And this is the whole process of the telomerization for preparing the fluoroalkyls. The final polymer which is applied to fiber should form a structure that represents CF3 outer layer for the maximum repellency. This is the structure of that polymer. The length of the perfluorinated side chain should be 8 to 10 carbon. The smaller spacer, mostly ethylene, can be modified to improve emulsification and solubility of the polymer. Most fluorocarbon-based products are padded, dried, and then cured. Heat treatment causes an orientation of the perfluoro side chain to almost crystalline structure. Washing and drying disturb this orientation and reduce finish performance. The orientation must be generated by the new heat treatment. With some new FC product, drying in air is sufficient. The isocyanate is activated at different temperature and react with the functional group of the fluorocarbon, the fiber, and with the itself, means cross-linking. The fixation on the fiber surface provides durability to washing, drying, rubbing as the second important effect. Booster also cause film formation and thereby higher repellency effect. What are the effects of blocked isocyanate as FC booster? High repellency, higher performance to washing, dry cleaning, lower curing temperature, LAD, laundry, air dry, volatile organic compound. And what is the effect? It is called by the better film formation, cross-linking, catalytic effects, higher FC efficiency. Low curing FC are another new development. They get their repellency without heat, only after drying at room temperature. This is of the interest of the impregnation of the garments and carpets. An inevitable advantage is their low durability because of the lack of the finishing of the cross-linking. Bionic finishes is basically the agglomeration of the FC and dendrimers. A novel FC development inspired by the nature and therefore called bionic finishes. Fluorocarbon polymer are applied together and dendrimers causing self-organization. Thus, where the fluorocarbon chain are enriched on the surface and psychocrystalline with the dendrimers. Dendrimers are highly branched oligomers with non-polar chains forming a star brush structure. The resulting polar and non-polar sandwich arrangements are highly ordered. One advantages include low condensation temperature, high abrasion resistance, and soft hand. This is the hypothetical structure of the dendrimers synthesized from the 3-diastereoamine or amides. Now, what are the advantages of the FC-based finishes and disadvantages of the FC-based? Advantages of the FC repellent finishes: low active adherence and more rapid drying treated fabrics. Special FC allow improved soil releasing during household laundering, which is especially useful for the carpets. If we are going to talk about disadvantages of the FC repellent, which include very high cost, it's very expensive, growing during laundering, potentially hazardous aerosol, the need for the special treatment from the waste application process. But there are some FC-based products that are accepted in this role. So there are testing parameters which evaluation are done of the textile treated with the repellent finishes. Rapid and simple tests for the water repellency are the water drop test, method standardization, and the spray test. Physical and chemical testing. Each sample were tested in the standard atmosphere and the temperature are 25 degree. GSM test. GSM test was done by the GSM cutter from the James, and bursting strength test was done by the bursting tester from the SDL according to the ASTM. Air permeability test, color fastness to wash test, color fastness to water, color fastness to chlorinated water, color fastness to perspiration, color fastness to rubbing. These are the physical and chemical testing that should be done on the fabrics. If there is an insufficient differentiation, even with the higher distance between the sample and the nozzle, the water resistance with the hydrostatic pressure test should be checked. Some of the most important quantitative tests are mentioned in this table. For the fabrics that require durability, AATCC TM 124 and TM 86 in order to determine durability of the repellency properties are mentioned in the next slide. Three groups of the corresponding test method may be distinguished: static drop test, spray test, and hydrostatic pressure test. These are the tests which are used for the repellency of the durability. Treated fabric is stretched, in which the first test in which the water repellency spray test, and the second one is the pact of the penetration test, and the third is the rain test. So what are the troubleshooting for the repellent finishes and particularities? Any residual sizing agent or surfactant present on the fabrics can defeat their repellency property. All the fabric destined for the repellent finishes should be well prepared prior to finishing. Non-repeating, thermally degrading, or volatile surfactants such as isopropanol should be used in the repellent finishes, but to maximize the final properties. Repellent finishes are usually compatible with easy use and durable press finishes and many softener. How most silicone products interfere with the oil repellency and the fluorocarbon finishes and should generally be avoided in oil repellent formulation. This is a marketable contract to the incorporation of the silicone segment. The combination of the anti and anti-static finishes achieved with the selected product is important for the synthetic microfiber textile. The other common finishes combination include hand builders, flame retardant, and antimicrobial agent, which basically generate valuable and useful multifunctional finishes. Condition for the high repellency of the finished fabrics include a closed pack textile with inner inter-yarn spaces with fine yarn and uniform distribution. This last condition is enhanced by the removal of the protruding surface fiber by singing process. FC finishes alone do not sufficiently prevent coffee, tea, other foodstuff from dyeing nylon food carpet. Stain blocking for these carpets is achieved by the combination of the FC product with scented. Stain repellency is promoted by the hydrophobic finishes, mostly by the FC, but with the decreasing cost also by silicone fatty acid modified melamine product and by the paraffin waxes mixed with the zirconium salt. Now I'm going to talk about the nature of the repellent finishes to reduce the adhesion. Silicone and fluorocarbon polymers cannot easily be stripped off, especially when they are cross-linked, as it is the nature of the repellent finishes to reduce the adhesion. There are problems with the backcoating and laminating of the fabrics finished by the padding fluorocarbon. And the solution to this application is nip padding, spray, foam, and squeeze technique. Now I'm going to talk about the environmental effects of these repellent. So, environmentally critical products, long-life byproducts of the FC synthesized by the electrical chemicals fluorinated are perchlorosulfonic acid and their corresponding salt, perchloroctyl sulfonates. These environmentally critical with this concern about the persistent bioaccumulation and potentially toxicity are avoided by synthesis via telomerization. Environment friendly FC. Two environmental friendly short chain FC oleophobal and phobal are evaluated on the cotton fabrics. The fact of the combination of these two FC and the combination of the oleophobal with a zero formaldehyde crosslinker to enhance the performance and durability was also scrutinized. Repellency performance of the treated fabrics are appraised by the measuring water repellency, and the contact angle washing durability of the finished fabrics was also enhanced by the incorporation of the crosslinker in the recipe of the Illyria fall. The physical and the comfort properties of the fabrics are also examined by measuring the tensile strength, shear strength, and water vapor permeability of the fabrics. New durability water and oil repellent product used in the textile industry. Midward Life is a project confirmed by the Life Plus program that aims to reduce the impact on the environment, human health, and the worker certify on the durable water and oil repellents used in the textile industry and their alternative by analyzing their environmental impact and technical functionality. New durable water and oil repellent product used in the textile industry. Main used obtained are the selection of the durable water and oil repellent product to be studied under the project. Two current durable water and oil repellent and 7 alternative short chain fluorocarbons are selected. The selection of the fabrics on the are applied was done according to the application of the final product. Then selecting application are carpets for the automotive, t-shirts for the sports. After the selection, a pre-screening of the functional and the environmental impact was carried out. It provides a map for the technical performance of the environmental and health impact on the chosen durable water oil repellent. Perfluorooctanoic acid and PFOS and PFs. PFOA has been classified as a substance with a very high concern because it has carcinogen, mutagenic, and toxic for the reproduction and persistent bioaccumulated toxic properties. So it can cause very health problems if it is eliminated directly into the environment. Based on their PTB and CMN properties, it has been identified as a substance of high concern under these companies. Germany and Norway have submitted a report proposing a restriction on the manufacturing uses and placing on the market and assault, including the substance that degrade to PFOA having greater than 2 parts per billion. The proposed restriction also covers articles containing these substances. Restriction to these use of the PFOS and its derivative are published in UA regulation. So, although successful in the providing water and oil repellent properties, perfluorocarbon products are in the blacklist of the Environmental Association due to their toxicity. Thus, new trends of the water and oil repellent finishes with the minimum side effects on the human and environment are more demanded. In this regard, nanotechnology has been brought valuable achievement and further investigation will be focused on the future. Finishing methods based on the nanostructure surfaces roughness will be of high importance to produce both of the fluorine-free repellents, nanoparticles, and the application method resulting in the water or repellent property along with the multifunctionalities as self-cleaning antibacterial retardant should be considered in future. So that's all from my side. Thank you very much.